Okay, so this is a poll conducted in 2013 found that 52% of U.S. adults, Twitter users, gets at least some news on Twitter. The standard error for the estimate was 2.4%, and a normal distribution may be used to model the sample proportion. Construct a 99% confidence interval for the fraction of U.S. adult users who get some news on Twitter, and interpret the confidence interval in context. So the first thing you might want to do is go to our Blackboard page. If you go to our course materials here and go down to additional resources, there is a formula reference sheet right here. Okay, click it. It looks like this. You don't really need this too much because most of the stuff is done in the calculator, but for this particular problem, we're going to use it. And we're talking about a confidence interval for a proportion. So I'm going to be looking right here. Okay, so the form of our confidence interval is going to be our point estimate, which is p hat plus or minus z of alpha over 2 times the standard deviation with respect to p hat. Okay. Now, the thing to remember is that this is also called the standard error. Okay. So we can use this formula to come up with our interval. So it's just going to look like this. P hat is our point estimate, or the percentage given. So that's going to be 0.52. I'm looking for the z value that cuts off the inner 99%. So if I look at the normal curve, I'm never really good at drawing these. Yikes. I'm looking for the values of z that cut off the middle 99%. So I'm looking for this guy. Okay. And then I have this here, it tells us is 2.4% or 0.024. Okay, so I just need to find that z value. So if I go to my calculator, I'm going to hit, let's get all this out of here. I'm going to hit second, distributions. I want an inverse normal. I'm looking for the z value that cuts off the middle 99% or the bottom 99.5%, right? Because there's 5% here, 5% here. So I'm just going to plug in 0.995. Mu is 0, sigma is 1 because it's normal. It's a z-score. Hit enter, enter. So our z value is going to be 2.5758. So actually, I should move this over. Whatever, I'll just rewrite it. This is 0.52 plus or minus 2.5758. I think that's what it was. Yep, that's good enough, times my standard error, which is 0.024. I'm not sure if there's a problem like this on the problem side of the quiz. I think most of the stuff on those can be done in the calculator. But here we go. I'm going to first figure out what this thing is. This 2.57, yada, yada, yada. So I'll take this number, multiply it by 0.024. Okay, that's my margin of error. So I'm going to take my point estimate, 0.52, subtract that. That'll be my lower bound. So it looks like we'll have 0.4582. And then I'm going to take that same thing, but I'm going to change that minus to a plus. And I get 0.5818. Okay, it wants it written as percentages. I see these little percent signs. That's very subtle. So I guess we'll write 45.82% and 58.18%. Okay, So then what does that mean? So let's look at the interpretations. It says 99% of confidence intervals will contain the correct sample proportion of the US adult Twitter users. They get some news from Twitter. There is a 99% probability. This doesn't really have anything to do with probability. Okay, so we're not talking about that. We are 99% confident that the true proportion of US adult Twitter users get some news on Twitter is within our confidence interval. I mean, A and C are really similar, so I'm not sure I would really dock you for getting this wrong. But technically, it says we are 99% confident that the true proportion of U.S. adult Twitter users who get some news on Twitter falls within this range. Okay, so your answer here is going to be C. All right, let's move on. That was 49. This is 52. It says the National Survey of Family Growth conducted by the Centers for Disease Control gathers information on family life, marriage and divorce, pregnancy, yada, yada, yada. One of the variables collected on this survey is the age at first marriage. I'm not sure why there's an arrow there, but the histogram below shows the distribution of ages at first marriage of 5,534 randomly sampled women between 2006 and 2010. Average age of the first marriage among these women is 23.44. So we say X bar. I don't know if we're going to need it, but let's just write it down. It's 23.44. We have a sample of 5,534 people. So this is all really, we don't need any of this. It just says estimate the average age at first marriage of women using a 95% confidence interval. Okay, so we don't know. Oh, we do. Okay, so it says the average age of first marriage is 23.44 and with a standard deviation. So we have sigma. Okay, so we have, let's see here, that's S is 4.72. Okay. So the first thing you want to kind of take note of here is, do we know S or sigma? If we know sigma, that's going to imply a Z interval. Okay. If we have S, which is the same thing but based off of a sample, we have to use a T interval. And again, you won't use it too much, but if you look at the formula sheet, you'll see confidence intervals for a population mean. We have two cases where sigma is known and sigma is not known. Now notice the only difference here is there's a Z here and a T here. So that just tells you which function in the calculator to use. So if I go back to the problem, it says we have X bar, N, S, we're good to go. I'm going to go to my stat menu, over to tests, since I don't know sigma because this is based off of the sample. Okay, the average age of the first marriage among these women is this and this. So it's an S, not a sigma. So we're going to use a T interval. And we're not going to use data. We don't have data. We're just going to use the statistics given. So our X bar is 23.44. Our sample standard deviation is 4.72. And our sample size is 5,534. And we want a confidence level of 95% or 0.95. And plugging that in, we get 23. Let's see here. Does it say number of decimals? Never does. 23.316 up to 23.564. Okay. Again, if this all was the same, but they said this was like the population standard deviation, if they mentioned population standard deviation, so this was now sigma, you would use a Z interval instead of a T interval. And the last one says, is college worth it? Exercise, yada, yada, yada. A poll where 48% of 331 Americans who decide to not go to college do so because they cannot afford it. Calculate a 90% confidence interval for the proportion of Americans who decide to not go to college because they cannot afford it. So we're going to use the calculator. And if you notice, there's really only 3 commands you can use for confidence intervals. You have the Z interval, the T interval. That's depending on if you're talking about means or not. And if you're talking about proportions, the only real option we have is a one proportion Z interval. So if you go to that, let me clear this out. Stat over to tests, go down to one prop Z interval, option A. You'll see it has an X and an N here, okay? This gives us a percentage. X is the number of things that are successful out of the population. So our population is going to be 331. But you're not going to put 48 here because X is not 48. X is the number of people out of the 331 who said that they didn't go to college because they couldn't afford it. So if I quit out of this real quick, I need to figure out what's 48%, 0.48 times 331. So we'll round to the nearest person. So we'll say 159 people. Okay, 159 people. So really we can say 159 people of 331 said something. So back to stat, back to our tests, one prop Z interval. So the number of people out of my sample that satisfy whatever we're talking about is now 159. Don't use the percentage. Sample size is 331. And we want a 90% confidence interval, 0.90. Now we can calculate, and we get our lower bound to be, it's 4 decimal places. See, this is why it's so confusing, because now it doesn't want a percentage. So this is going to be 0.4352 up to 0.5255. Okay, so let's look at the interpretation. We can be 90% confident that our confidence interval contains the sample proportion of Americans who chose not to go to college because they cannot afford it. 90% of Americans chose not to go to college. That doesn't make any, that has nothing to do with our information. We can be 90% confident that the proportion of Americans who chose not to go to college because they cannot afford it is contained within our interval. Okay, similar to the first example.